So today we have NASA Solar System Ambassador Pat Monteith, and she is going to be filling us in on the James Webb Space Telescope.
Thanks so much, Stephanie. So a little bit about me. I've been a solar system ambassador for about 7 or 8 years, and I've probably done 150 different programs over the past, 7 or 8 years. And I've actually done a program about the James Webb Space Telescope for the OSHA Lifelong Learning Program at UMass Boston. And one of their satellite facilities is the Thayer Library in Braintree. So this is somewhat the same program, but I've added some more, updated more information about it. So you're going to get some latest information actually as of 2 days ago. Okay. So does anybody here consider themselves a space expert or know about space? So a little bit about my background. When I was Landon's age, and in the 6th or 7th grade, I fell in love with the space program. And I'm going to date myself by saying this. And it had something to do with John F. Kennedy saying, we're going to land on the moon by the end of this decade. And it just intrigued me. And so even though I had a whole different career for 40 years, nearly 40 years, and I'm sure you all understand that, I stayed in love with the space program. And so when I retired from UMass Boston about 9 or 10 years ago, I found out about this NASA Solar System Ambassador Program, and I was like a little kid in a candy shop. It's like, me, can I do it? Can I do it? And I was telling a few people up here that one of the things that NASA did was ask for 7 references. They checked all 7 of my references. Thank goodness they went okay. So I actually have access to thousands of scientists and researchers and webinars, and so I'm constantly getting myself up to date about a whole variety of different space programs, and this one is absolutely incredible. So if we can shut off the lights, Grady, and let's see, does that help? You okay?
Yeah.
Can you put on like one of the lights, maybe? No. Okay. All right. All right. So, can everybody see the monitor? Okay. Okay. And you can all hear me. All right. So let's see if we can make it through here. And I'm really thrilled to be here. The first time I was here at the Senior Center was about a week ago to check out the space. And this really blew me away. This is such a beautiful facility in such a beautiful setting. You're all so lucky. I almost moved to Lakeville about 12 years ago, but that didn't happen. But now I wish it did. Okay, so, in its first 100 days, what happened was actually a year ago, right around Christmas time in 2001, the James Webb telescope was launched from New Guinea. And it took about 6 months for NASA to be able to get all the kinks out of it and to make sure it worked. And it was around the 4th of July, and NASA started releasing some photos. And in its first 100 days, it peered very deep into space, took unbelievable shots of the galaxies and nebulae, saw a spacecraft slam into an asteroid, and all sorts of stuff like that. Absolutely amazing stuff, and it continues today. As I said, I've got some information about a story that just happened a day or 2 ago with the Space Webb Telescope. So it's really been pretty phenomenal. It's been really amazing, and you're going to learn about it, and some of the photos are just absolutely breathtaking. So what I like to do is I like to make sure that everybody is on the same page when I start talking about some of this stuff, because, like a space geek, I throw words around like solar system and galaxies and stuff like that. And I want to make sure you all understand what they're about. So our solar system consists of the sun, and not just our solar system here, but Huh? Okay, so a solar system consists of the sun and everything bound to it by gravity. Everything in the universe is bound by some sort of gravity. In our solar system here, it includes the 8 planets, and no, Pluto is not a planet. Maybe I'll come back and do another program about that, but Pluto is no longer considered a real planet. And the moons, and there's lots of moons around different planets, asteroids, dwarf planets, which is what Pluto is now, the Kuiper Belt objects, meteoroids, comets, and interplanetary dust. Okay, so that's a solar system. A galaxy is a huge collection of gas, dust, billions of stars. Okay, our sun is a star. So if I talk about a star, if I talk about the sun, it's really the same thing. The universe consists of billions of galaxies, and we really didn't know this until about 20 years ago. We live in the Milky Way galaxy, which is one of, and it's a real number, 200 plus billion galaxies that exist in our universe. And the universe is everything. It's all of space and matter and energy, time, and all its contents, including planets and stars and galaxies and everything else. So in summary, we live on planet Earth, which is part of our local system. Our solar system includes the sun and everything that orbits the sun. Our sun is just one star in the Milky Way galaxy. And I'm going to show a video in a second, and I'm going to stop to give you a good view of the Milky Way galaxy. And it's just one galaxy in the universe, and the universe is the totality of everything. All right, so first, a brief video about what the goal was for the James Webb Space Telescope.
We have uncovered wonders undreamt by our ancestors who first speculated on the nature of those wandering lights in the night sky.
Okay, so I'm pausing here. That what looks like a bunch of dust and clouds, that's actually our Milky Way galaxy. And if you ever have a chance to go up to like northern Maine or northern Vermont or out west, that's exactly what you see. And I've had the pleasure of seeing that, and it's really breathtaking.
We've crossed the solar system and sent ships to the stars. But we continue to search. We can't help it. A central element of the human future lies far beyond the Earth. If we crave some cosmic purpose, then let us find ourselves a worthy goal.
So a model of the James Webb Space Telescope is actually on that back table back there. And I'll talk about that in more details in a little while and how it all operates. But it's a pretty amazing thing as it folds like origami. So you'll see another video in a little while that'll show you how the pieces of the James Webb Space Telescope actually folds and unfolds like some origami. All right, so in astronomy, we study the universe by gathering light. A lot of people don't realize that. Using visible light alone, however, is incredibly restrictive. And I'm sorry, but these monitors don't allow me to point to certain things. They block out for whatever reason. I think, yeah, see, I can show you up here, but I can't show you on the monitor. But when we take a look at light, you can see that the visible spectrum, which is if we take a look up at the sky, That's all we can see. We can only see a small portion of light. And the James Webb Space Telescope actually uses infrared light to take a look at the rest of the universe. And we'll talk some more about that in a minute. So telescopes have changed our understanding of the universe as far back as 1610. From the dawn of humankind, only 400 years ago, all we knew about our universe came through just looking at the sky with our naked eye. In 1610, Galileo came about, and he created a telescope, and he learned by looking through that telescope that Saturn had rings and Jupiter had moons, and that nebulous patch across the center of the sky, our Milky Way galaxy, is actually billions of stars. Telescopes progressed over the following centuries. Edwin Hubble came up with some phenomenal improvements to the telescope in 1920, and used the largest telescope available then to discover galaxies beyond our own, which is pretty amazing. And so when the Hubble telescope was created and launched in 1990, they named it after Edwin Hubble. Okay, so the Hubble Space Telescope. So before we talk about Webb, we really need to talk a little bit about Hubble, because Hubble really created an awful lot of amazing photos for us and information. The Hubble telescope is an observatory. It's the first major, what's referred to as optical telescope, to be placed in space. And what's important about that is most people don't realize that on Earth, there's the atmosphere to have to deal with, and light pollution. You don't have as much light pollution down here in Lakeville as I do up in Brockton. I can't see the sky hardly at all. But here in Lakeville, you can see the sky. There is some light pollution, but not as bad as I've got it. And so Hubble helps us observe the universe above all the atmosphere and light pollution issues. Some fast telescope facts, which I think are pretty amazing. Since 1990, Hubble has gone more than 4 billion miles circling or orbiting Earth. That's an amazing figure. It just keeps going around and around. It has the pointing accuracy of what's referred to as 0.007 arc seconds, which is like shining a laser beam on President Roosevelt's head on a dime from 200 miles away. You can see the details of that. With its optics, you can see a pair of fireflies in Tokyo from Washington, D.C. that are less than 10 feet apart. It's absolutely amazing. And it's peered back into the very distant past to more than 13.4 billion light years. Okay, so I got a quiz I'm sure that Landon can answer, but let's see if somebody else can answer it too. Okay, what is this?
Big Dipper.
Okay, right, it's the Big Dipper. The first time I saw this, I was really blown away. I was absolutely amazed with this. Okay, Hubble's greatest discovery happened 5 years after it was launched in 1995. And they had Hubble stare at this one area in space for 100 hours. Okay, think about that. It looks like there's nothing there in that red square, red rectangle above the ladle of the Big Dipper. And you know what it discovered? Oh, my goodness. This is what Hubble found by staring at that one part of space. Thousands of galaxies. And we're going to talk some more about galaxies in a little while. But the first time I saw this, it just knocked me off my chair, literally. Okay, so, Hubble has made over 1.3 million observations and discoveries, as I said, since 1990. And if I blew up every single one of those, little pictures or graphics, you would see everything. Some of the stuff was amazing. So now we're going to talk about what's next after Hubble. Well, what's after Hubble is what we have now, which is the James Webb Space Telescope. So James Webb looks like that, and you know the mirrors actually look like what I have a model of back there. It's considered the successor, not a replacement. So Hubble's going to stay in place in addition to James Webb. It's actually, the Webb telescope is 100 times more powerful than Hubble. And you can see here on the right how the difference in height and how big the diameter is of Hubble versus the primary mirrors here at the James Webb Space Telescope. Hubble is only a little bit bigger than a human being, where James Webb is much bigger, so it's much more powerful. It compares back in time further than Hubble. It looks, as I said earlier, it looks at the universe in infrared, the infrared part of the spectrum, rather than visible light, where Hubble was only looking at the universe in its optical and ultraviolet wavelengths. Observations of really distant galaxies with real detail. Again, you'll see some of the photos that's going to amaze you. Requires infrared telescope, and you'll see why in a little while. And it's one of the main differences is Hubble actually orbits Earth, where James Webb orbits the sun, like the Earth does. And I've got another photo. So again, we go back to the electromagnetic spectrum, where you can see here Hubble only looked at the visible spectrum. James Webb is looking at infrared, and Spitzer Space Telescope, which didn't quite work the way they intended to, also looked at infrared, but nowhere near as powerful as James Webb, and it's now defunct. All right, so this again gives you a difference in a view of Hubble versus James Webb, and where the mass and the size of Hubble appears to be bigger than James Webb. They're very, very different. And you'll see that James Webb is built very differently. Here's James Webb. What happens is there's the primary mirror that you can see. Again, we have the model back there, and it sits on top of different layers to help provide a heat shield. Because one of the big problems with space telescopes in particular is the heat can actually burn up the telescope if you don't find ways to deal with it. Here's the bottom side of the Webb telescope, and you know there's a solar power array, so that's how it actually keeps power, and the antennas communicate back with Earth. Hubble, as I said, was launched in 1990. One of the big things here is the operating temperature. And as you can see, the operating temperature for Hubble on the left is about 28 degrees centigrade, which isn't that bad. However, James Webb operates at minus 223 degrees Celsius. Wow, big difference. And so this is why James Webb had to be more protected in a lot of different ways. And as you can see in the bottom down here, Hubble orbits the moon, whereas Webb is out, 1.5 billion kilometers from Earth, and it actually orbits the sun. Okay, and that gives you an idea right there, another view of the difference with the orbit between Hubble and Webb.
Question?
Sure.
It's geosynchronous with the Earth though, right? It's moving, it's outside, much farther away, but it's moving with the Earth.
Right, and it's in a space called, it's a Lagrange point, if you understand Lagrange points, but it's L2. And actually I learned a lot about Lagrange points. I actually wrote a book for middle school students that involved Lagrange points. And my publisher said, there's no such thing. So I had to go through several weeks of convincing her that yes, there is, and this is what it's all about. All right, so let's take a look at some of the goals of James Webb. And let's see if, in fact, this is going to... Oops.
So one of the wonderful challenges about astronomy is that we have to imagine something so we can go look for it. But nature has this way of being even more creative than we are. So we have always been surprised by what we see in the sky. That's why building a telescope has always been interesting. Every time we build a better one, we see something we never imagined was out there. That's been going on for centuries. This is the next step in that great series of a bigger, better, more powerful telescope that will surely surprise us in some way that I can't tell you.
So the James Webb Space Telescope at its core is designed to answer some of the biggest questions we have in astronomy today. And these are questions that go beyond just being science questions. They're questions that really get to the heart of who we are as human beings. Questions like, where do we come from? And how do we get here? And of course the big one, are we alone? To answer the biggest questions in astronomy today, we really need a very big telescope. And the James Webb Space Telescope is the biggest telescope we've ever attempted to send into space. It really sets us up with some really big engineering challenges.
It had never been done before to build a big unfolding telescope in space, because we knew we needed something that was bigger than the rocket to achieve the scientific discoveries that we wanted to make. We had to invent a new way to make the mirrors, a way to focus it in outer space, several new kinds of infrared detectors. We had to invent the big unfolding umbrella. We call it a sun shield.
Webb has 4 broad science goals: to detect the very first stars and galaxies that were born in the very early universe. So this is a part of the universe that we haven't seen at all yet. We don't know what's there. So the telescope, in a sense, is going to open up this brand new part of the universe, the part of the universe that got everything started. To search for the first galaxies that were born after the Big Bang.
The first stars and galaxies are really the big mystery for us. We don't know how that happened. We don't know when it happened. We don't know what those first stars were like. We have a pretty good idea that they were very much larger than the sun, and that they would burn out in a tremendous burst of glory in just a few million years.
To watch how galaxies grow and change over time. We have questions like how galaxies merge, how their black holes form, and how gas inflows and outflows affect galaxy evolution. But we're really missing a key piece of the puzzle, which is how galaxies got their start. To find stars and planets born inside dusty clouds, and to help in our search for life in the universe.
So astronomy is one of the most observationally based sciences we've ever had. Everything we know about the sky has been a surprise. Ancients knew about the stars, but they didn't know they were far away. They didn't know that they were like the sun. Eventually we found that our own galaxy is one of hundreds of billions of galaxies, and that the universe is actually very old, but not infinitely old, so that was a big surprise too. Einstein thought, of course, the universe must have an infinite age, without a starting point. Well, he was wrong. So our intuition has just been wrong almost all the time. We're pretty confident that we don't know what we're going to find.
As an astronomer, one of the most exciting things about working on a telescope like this is the prospect of what it will tell us that we haven't even thought of yet. We have all these really detailed science questions that we'll ask, that we know to ask, and that we'll answer. And in a sense, that's what science is all about. You know, in answering the questions, we come up with more questions. So there's this almost infinite supply of questions, of things that we have to learn. So that's why NASA builds telescopes, is really to get to this fundamental part of who we are as human beings. You know, we're explorers, and we want to learn about what our universe is like.
Absolutely amazing technology, if you ask me. Okay. So the James Webb Telescope was created, especially the sun shields were created to be able to absorb what's called meteorites flying through the sky. And, you know, they assumed they knew how much of an impact it could have. However, back in May of last year, May 24th, there was a meteoroid so large that it actually damaged one of the mirrors on the Space Telescope. It took them about 3 months to figure out how much of an impact that had. Everything that's come out of NASA says it's minimal impact. I don't know, and we'll find out at some point in the future when we need that part of the mirror. Okay, so one of my most favorite parts of photos that come out of the universe, and has for many years, is called the Pillars of Creation. I've always found this really, really fascinating. And it's part of a nebula called the Eagle Nebula, which you can see on the right side, and that's a blow-up of it on the left. And nebulas are actually a nursery where stars are born. So we're going to take a look at some more of the nebulas at some point coming up, and taking a look at the differences between how Hubble sees it. And that picture on the left is something that Hubble has created and sent down to us. And when you see the difference between how James Webb does the same picture, you'll be kind of amazed. So let's take a look at some of the difference between the evolution of different infrared space telescopes. So WISE back in 2003, that's what the infrared telescope could see at a particular point in the universe. In the middle photo is Spitzer, which came, back about 6 or 7 years later. And then here's James Webb. And so we're taking a look at the same part of the sky and able to see the details in much greater clarity than we ever would have back, in 2003, 20 years ago. So the telescope and the quality of the telescope has absolutely advanced to a point where you could see in this far right-hand photo that you can see stars and galaxies like you just never ever expected to see before. So we're going to take a look at some of the Webb's first images. These are the first ones that were released back in July. And these are the ones, when I talk about, these first images from Webb really as spectacular as they were hoping it would be. And so we're going to take a look at 5 of the different photo releases and information releases from NASA about the first science images. All right, so the 5 that we're going to take a look at is the Carina Nebula, Southern Ring, this galaxy cluster over on the bottom right-hand side, something that's an exoplanet. And exoplanets are planets outside of a solar system. Not necessarily just our solar system, but as I said, there's lots of solar systems out there. And there's some information about why it's very difficult to take a look at and find exoplanets. And this is where, when we start talking about, are we alone in the universe? Is there anybody else out there? Do they look like us? Do they look like something different? We're going to find those on exoplanets. So that's going to be a very important part of what James Webb looks like. And then there's Stephan's quintet. And when we get to it, I think you're going to laugh when you see what it's all about. Okay, so we're going to take a look at this first deep field image. This was the one that was released when President Biden was there the night before they released all the other photos. And here's a part of the a cluster of galaxies in the southern constellation. On the left here is James Webb looking at that area of the constellation. And here's the difference with what James Webb sees. It's the exact same photo of space. You can see so many more details, and we'll talk more about some of the galaxies and those things that look like they're lines throughout, and we'll see what those are in a little while. Okay, so this part of the cluster has different things that you can see. When you see something, you can see the blue circle there. That shows that there's a little gas there in that part of the galaxy cluster. The red area, thick layers of dust, and greens are hydrocarbons and other chemical compounds. These things here that, as I had said, look like they're lines that are moving, or semicircles or whatever, that's called gravitational lensing. And what actually is happening is behind that galaxy, there's more galaxies. You just can't see them. And so this is the way they project out on the James Webb Space Telescope. It took a while to understand that, but I think I now understand it. Oh, okay, so there's another one right there. So you can see right there how these distortions, you don't know what those are, but those are actually galaxies behind each other. You can only see the one in front, but it looks like some sort of something that's moving. Oh, there's another one up there and another one there. I forgot what I did. All right, so when we're taking a look at exoplanets in particular, we can't really see the details yet of exoplanets, even though there's something that was released 48 hours ago that says that Webb actually got a good picture of an exoplanet. But one thing that we could see with Webb is the atmosphere and the different wavelengths of different chemicals. So here on Earth, we see, carbon dioxide, we can see the water that we have here on Earth, methane, which is an important part of it. You can see the ozone, whether we want to or not. But this is what we can, and what Webb can discover about different planets and exoplanets. But that's a signature of Earth. So, as I said, exoplanets are planets outside of solar systems, not only just our solar system, but other solar systems out there. And there's different types of exoplanets, and I'm not going to go into any details, but in comparison to Earth, are they like Earth? Are they, like other planets in our solar system, like the gas giants? As I said, I'm not going to go into the details. But so this exoplanet here, and everybody was confused when they first saw this come out of NASA in the first day or two of photos that were supposedly released. And so what NASA released was the chemical signature of an exoplanet called WASP 96b. Don't ask me why they named it that. I really don't know. But you can see here, this one exoplanet, it's got water, H2O. It's got carbon dioxide. It's got a lot of the building blocks of what we consider to be life here on Earth. So when NASA released this, they had to explain that, exoplanets are really very, very dim. So the James Webb Space Telescope uses what's called spectroscopy to spot the smaller planets that might be hiding behind the sun. So this was one of the first 5 releases that NASA had to talk about what they found with the James Webb Space Telescope. All right, so here's Stephan's quintet. And this is something, and it shows interacting galaxies. And there's actually 5 galaxies here. And, one of the things that James Webb has discovered is how multiple galaxies interact when they merge. So this one on the bottom right here, there's actually, if you look very carefully, you can see that there's 2 galaxies right there. So, so that I don't get too surprised, let me see what is going to come up here. Okay. So here's the difference, again, between Hubble on the left and James Webb on the right. And you can see many, many, many more details. You can see more galaxies, you can see many more stars. So this is going to surprise a few people. Has anybody seen the movie It's a Wonderful Life? Is there anybody that hasn't seen it? Okay, only a few of you. Okay, do you have any idea what I'm about to show you? At the beginning of It's a Wonderful Life, they showed these angels talking to one another about the main character in the movie.
Send for Clarence.
You sent for me, sir?
Yes, Clarence. A man down on Earth needs our help.
Splendid. Is he sick?
No, worse. He's discouraged. At exactly 10:45 p.m. Earth time, that man will be thinking seriously of throwing away God's greatest gift.
Oh, dear, his life. Then I've only an hour to dress. What are they wearing now?
You will spend that hour getting acquainted with George Bailey.
Sir, if I should accomplish this mission, might I perhaps win my wings? I've been waiting for over 200 years now, sir, and people are beginning to talk.
What's that book you've got there?
Oh, The Adventures of Tom Sawyer.
Clarence, you do a good job with George Bailey, and you will get your wings.
Oh, thank you, sir. Thank you.
Poor John. Sit down.
Sit down. What do we...
If you're going to help a man, you want to know something about him, don't you?
Well, naturally, of course.
Well, keep your eyes open.
So I'm sure you all saw that and had no idea. That was back in 1934, and they actually showed Stephan's quintet. Now I'll go back a slide or two. Right there as part of that film, 1946. And, you know, the angels talking to one another, and they're talking about Clarence going down and helping to save George Bailey. But if the next time you watch this movie, you're going to be amazed, but it was back in 1946 that Stephan's quintet was really something that the movie industry actually found that and found some photos of it, which is really cool.
Send for...
Go away. Okay. So the Southern Ring Nebula is made up of gas that's ejected by stars near the end of their lifespan. And so we can see that picture in Hubble. And then again, here's James Webb with much more detail and many more pictures of stars. And there's actually a galaxy there that we didn't know existed. And okay. Then there's the Carina Nebula. This is one of, again, the 5 first photos that NASA released. And every dot here is an individual star, like our own sun. Oh, wow. So now you see the difference, some of the differences between, you know, what James Webb can see with its infrared cameras and telescopes versus what we've been able to see up till now. So when we take a look at the pillars of creation, this is a part of the pillars of creation, which a very small section of it that I showed you before. And we'll go to the next one in a second. But again, here's what Hubble could see versus what James Webb could see. And, you know, there's a lot of questions. When NASA first looked at these photos, it's like, what determines the number of stars in the region? You know, why do stars form with different masses? That's a very big question. What's the impact of star formation on the evolution of gigantic clouds? And, you know, what's the influence of numerous low-mass stars? Again, here's the details of the pillars of creation, and here's what Hubble saw, you know, 20 years ago. And here's what Webb sees now. Okay. We now know there's billions of stars and billions of galaxies out there. And of course, this advances the conversation of, are we alone? When we now see that there's billions of stars and galaxies, can people actually say We're probably not alone in the universe. I just love this, I really do. All right, so I'm going to end with one more video, which gives an overview now. You get a real overview of what the James Webb Space Telescope is all about. Now you'll understand it from a different perspective, seeing this all come together.
This tiny speck is the oldest and most distant galaxy ever seen by mankind. It's made up of stars, gases, dust, and dark matter, all held together by gravity. It's at least 13.5 billion years old. And this photo clearly shows individual star clusters for the first time ever. You can see between hundreds and millions of stars, all held closely together by gravity. NASA's James Webb Telescope, its newest and most powerful one yet, captured these in July. We looked at 6 of Webb's most recent images to see how NASA is using them to understand faraway galaxies. This is the telescope's first ever image of a planet outside our solar system. Scientists call it the HIP 65426b. As far as planets go, it's one of the youngest. It's only about 15 to 20 million years old. Earth's age is 4.5 billion years. But this planet is nothing like ours. It could be as much as 3,800 times heavier. And there's no rocky surface, so no one could live there. It's basically just a massive collection of gases. This shape here is the planet's host star, like our sun. The bright light from stars often hides planets, making it difficult for scientists to even discover them. But Webb has a strong light filter called a coronagraph, which is finally allowing experts to study distant planets. The new telescope also sees infrared light, which exposes molecules like water, carbon dioxide, and methane, critical to life as we know it. And for the first time, Webb found carbon dioxide in the atmosphere of a planet outside our solar system, about 700 light years away. This image shows the heart of M74, also known as the Phantom Galaxy. Its spirals are so well defined that scientists often study it to understand why some galaxies are shaped this way. This one sits in the constellation Pisces, almost face-to-face with Earth, but 32 million light years away. NASA's Hubble telescope took this photo. Here, it's hard to see anything but clouds of gas at the galaxy's core. That's because Hubble picks up on ultraviolet light, which these gases emit. But Webb doesn't, so it can see what's happening underneath the gases. Webb has also revealed images of stars dying. These 2 photos show the same phenomenon under 2 different infrared filters. Here we see the dying star, which scientists call a white dwarf. It's shedding its outer layers. These rings are made up of gases and dust. This star emitted them for thousands of years after it died. This brighter star is also dying. It hasn't started shedding yet, but it's orbiting the dwarf and spreading gases all around. Scientists say these photos are important in understanding what might happen if our star, the Sun, died. And here, Webb captures star birth. Astronomers call these the cosmic cliffs, located inside the Carina Nebula. That's a star-forming region about 7,600 light years away, but still within our own Milky Way. New young stars up here are producing radiation and strong winds, pushing gas and dust downward in this gigantic cloud. Scientists say dust clouds like these are breeding grounds for new planets and stars. They are already seeing hundreds of them here. And they're also noticing new types of cosmic structures scientists can't identify or name, like this thing right here. The telescope is also uncovering more about the planets we're already familiar with, like Jupiter. This is the clearest image scientists have ever seen of its northern and southern lights. seen in red, of its hazes shown in green and yellow, and of its massive storms, like the Great Red Spot shown in white here. It's a storm that's bigger than the size of Earth, with wind speeds about twice as strong as the most intense hurricanes. Scientists say seeing how storms on Jupiter work could help them understand Earth's weather systems too. The lightest spots in these images reflect high altitudes. With Webb, experts say they can determine the temperature at each level of Jupiter's atmosphere and the gases present. Until now, these thick layers of gas and dust have kept the planet's inner life a relative mystery. But Webb's images are so clear, they could help scientists change that. And while Jupiter is the biggest planet in our solar system, NASA says Webb is finally giving us the chance to explore faraway planets as tiny as ours.
Okay, so as I said, did you have a question?
I did. After it goes from the solar system, or the planet the sun dying, the dying process and shedding, does that go then into a black hole? I forget how the black holes are made.
Yeah, black holes actually capture lots of things. Some of them are dying stars, and some of it is what's referred to as dark matter. There's asteroids, there's all sorts of things. We really don't know much about black holes.
So they're not to follow on to a dying star.
They are in some cases, but not in every case. Okay. So here's something I actually captured this morning. And it's based on my taking a look at an article that came out yesterday or the day before. Oh, I forgot this doesn't work. In the upper left-hand corner, James Webb discovers its first exoplanet. Okay, so what's happening is scientists and researchers from all over the world can ask NASA to have the James Webb Space Telescope peer in on a particular part of space. So they actually call this the People's Telescope. And the reason is because people can actually say, you know, and there's a whole list of scientists that obviously are going to come first, are going to say, you know, peer into this one area of space. And every single day, not every week, every day, there's a new discovery. Which is just absolutely amazing and incredible, you know. But we can see here that, you know, the first galaxies may have formed much earlier than we thought. You know, the telescope notches the first rocky planet conformation. It's finding too many early galaxies. And what's interesting about that article is it means our beliefs about what created the first galaxies back, you know, 13.5 billion years ago, might need to be re-examined. It may not be exactly what we thought. You know, has it, you know, reveals stirred up secrets of breathtaking planet nebula, and you know, again, more stunning discoveries. So every single day, I mean, if you looked, and I'll show you this one here. For more information, you know, if you go to James Webb Space Telescope from NASA, the news section, every single day you're going to see another article about something else that James Webb has discovered, based on some scientists and researchers saying, you know what, I'd like to look at this one small area of space because I think there's going to be an exoplanet that we find, or we're going to find something else about galaxies. And that's exactly what's happening. And it's just absolutely amazing stuff. And I think that's it.